Hello there, thanks for joining us. This is Astronomy Daily. My name is Andrew Dunkley. I'm your host. Great to have your company and I hope you're very well. I'll give you a bit of a flood update too because we were talking about that yesterday, but things are much better here. The river is down back where it should be. The roads have all opened up. A lot of mud all over the place where the water rose. But essentially back to normal. Traffic's going where it can go as normal. Everything's fine, which is good news for us. Although downstream things are much worse at other towns. So we're remaining vigilant because it's not over yet. More rain expected at the end of the week. Good grief. But so far so good. We came out of that one pretty well. And thanks for thanks to all the people who sent their best wishes and asked if I was okay. Yep, all good. Joining me as always to talk astronomy and space science and keep us up to date with the news is Halley. Hi Halley, how are you?
Great to be here again, Andrew. It sure beats my second gig.
Second gig? You got another job. What do you do?
Oh, I do elocution lessons for Bixby.
Oh, okay. How's that going?
He's hopeless, to be honest. No wonder he could only get a TV gig.
I totally agree with you there. All right.
The Astronomy Daily Podcast with Andrew Dunkley.
Halley, you better get us up to date with the news.
The third and final module for China's space station has been filled with propellant in preparation for its journey into orbit later this month. The Mengtian experiment module arrived at the Wenchang spaceport on the southern island of Hainan in August, and has already undergone assembly and testing. The China Manned Space Agency announced that the module was loaded with propellant on October 9 ahead of its trip to space. Mengtian will use the propellant to help it rendezvous and dock with the two orbiting modules of the Tiangong space station. China launched the core module, named Tianhe, in April 2021 and sent the Wentian experiment module into orbit in July this year. Mengtian, which means dreaming of the heavens, is a 58.7 foot long or 17.9 meter and roughly structure, designed mainly to host an array of science racks and experiments. SpaceX has successfully deployed the first 2 of 7 satellites that Intelsat needs to clear the C-band spectrum in the United States, keeping the operator on course to launch all but one of them before the end of this year. A Falcon 9 rocket, carrying Galaxy 33 and Galaxy 34, lifted off from Cape Canaveral, Florida, and deployed the satellites into geostationary transfer orbit about 40 minutes after liftoff. The rocket's reusable first stage then successfully landed on a SpaceX drone ship in the Atlantic Ocean, following a record-tying 14th flight. A helium leak had forced SpaceX to scrub a previously planned October 6 launch, and a follow-up flight October 7 was also postponed. It will take about 2 weeks for the satellites to use onboard propulsion to reach their final geostationary orbit. Northrop Grumman built the satellites, which will help Intelsat move broadcast customers into a narrower part of its C-band spectrum to give more frequencies to terrestrial 5G operators in the United States. Intelsat stands to get nearly $5 billion from the Federal Communications Commission if it can fully vacate the lower 300 MHz sections of the C-band by the December 2023 deadline. The Pacific Ocean will disappear in about 300 million years, but not because of climate change. It'll be because of continental drift. Earth's 7 continents are distributed across the surface of the planet, with North and South America occupying one hemisphere, Africa, Europe, Asia, and Australia occupying the other, and Antarctica sitting alone around the South Pole. However, these continents were arranged entirely differently around 335 to 200 million years ago, and were surrounded by superoceans. Eventually, the Earth's tectonic plates will come together again to form the world's next supercontinent. According to new research led by Curtin University in Bentley, Australia, this will happen roughly 200 to 300 million years from now. The prediction was made using a series of simulations and suggests that the Americas drifting westward until they collide with Australia and Asia, thus eliminating the Pacific Ocean with Antarctica moving north to join them. This will give rise to the new supercontinent they have named Amasia. They also suggested that this will have profound implications for life on Earth. Although I expect most humans will be able to upload their minds to artificial bodies by then. And lastly, Andrew, visitors to Space Week got to taste space food, including an offering from JAXA, the Japanese space agency. Their astronauts are well fed too, with everything from rice balls to canned mackerel. People also tested mochi rice cakes, saya tagashi and takoyaki. While most of their foods are canned or freeze-dried, a dessert known as yokon is served as a gelatinous cube. And that's the news, Andrew.
Thank you, Halley. I've actually tried space food. When Judy and I visited NASA many years ago, we bought some space ice cream. It's freeze dried, and it's not like eating ordinary ice cream, normal ice cream. But I kind of liked it. Our boys didn't, though. We bought it for them, so I ended up eating all of it. We'll talk to you before the end of today's program, Halley, but to other news. And a New Zealand research institute has got into business with a US commercial firm called NanoRacks. And what they're doing is they're sending a superconducting magnet technology demonstrator to the International Space Station to test what's been described as a novel type of space propulsion. There's a lot of work going into finding other ways to propel us through space. Rockets are too slow and obviously a limited resource. So if they can find another way of doing it, all the better. The P. Howe Robinson Research Institute intends to test a type of electronic space thruster known as applied field magnetoplasma dynamic thrusters, which use high temperature conducting magnet technology developed by the Institute. Superconductors are materials that conduct electricity with zero resistance and therefore with much greater efficiency than conventional conductive materials. Now, most of these superconductors require temperatures close to absolute zero to operate properly, so that complicates the situation. High temperature conductors can operate at somewhat friendlier temperatures, somewhere around minus 321 degrees Fahrenheit or minus 162 Celsius, which makes their operations a bit cheaper. On top of that, HTS can generate stronger fields than low temperature superconductors, have a larger operational range and can be more compact, according to Robinson Research Institute in their statement. Be interesting to see how that experiment turns out because, if we're going to go into space long-term, long haul, we need to find a better way of doing it.
The Astronomy Daily Podcast
with Andrew Dunkley.
Now, hydrogen-eating methane that produces microbes called H2-based methanogens are likely to have existed in extensive numbers in the early life of Earth, and they still survive around deep ocean volcanic vents. New research in the journal Nature Astronomy suggests that Mars possibly had similar living conditions favourable to similar life forms in its past. According to Regis Ferreira from the University of Arizona's Department of Ecology and Evolutionary Biology, we're not dealing with a question of the origin of life on Mars. We are saying, let's assume that conditions were there for life to appear, and then let's ask the question of whether this original life could have persisted. Whether a more temperate Mars, rich in carbon dioxide and hydrogen and running on liquid water, could have sustained life 3.7 billion years ago is widely debated, but models simulating atmospheric and subsurface temperatures, chemistry and interactions support the possibility. And of course, we are up there looking for signs of this life right now. But to stay alive on Mars, microbes would have had to occupy a kind of Goldilocks zone in the porous, brine-drenched crust of the planet, deep enough to stay warm and receive protection from cosmic radiation, but shallow enough to exchange gases with the atmosphere. So there's a lot that comes into play, and that needs to be taken into account. The authors also suggest 3 areas of the highest probability of finding evidence of such microbes, one of which is Jezero Crater, where NASA's Perseverance rover mission is currently searching for past life on Mars. Now, a couple of years ago, it looked like space mining was an inevitability. And space mining companies like Planetary Resources and Deep Space Industries were backed by the likes of Google and a few other big-time operators. Well, let's fast forward to today and see where we're at. Both Planetary Resources and Deep Space Industries have been acquired by companies that have nothing to do with space mining. Humanity is yet to commercially mine even a single asteroid. So why is it taking so long? Space mining is a long-term undertaking and one that investors do not necessarily have the patience to support. And according to Joel Cecil, who's president and CEO of TransAstra Corporation, he says if we had to develop a full-scale asteroid mining vehicle today, we would need a few $100 million to do that using commercial processes. It would be difficult to convince the investor community that that's the right thing to do. He went on to say that in today's economy and the economics of the near future, it makes no sense to go after precious metals in asteroids. And the reason is the cost of getting to and from the asteroids, because it's so high and it vastly outstrips the value of anything that you could harness from asteroids. And Fred Watson's told me that a few times when we've discussed this topic on Space Nuts. But that hasn't disillusioned Cecil from trying to mine the cosmos. TransAstra will initially focus on mining asteroids for water to make rocket propellant, but would likely to eventually mine everything on the periodic table. So, yeah, it looks like it will happen one day. And finally, is there really an unseen mirror world where particles interact with our world only via gravity, but are otherwise impossible to observe? It sounds like a weird theory, but it's a research project that's been put forward about the solution as to why the universe is expanding more quickly than it should be. Now, what you need to know about is Hubble tension and why such bizarre theories are being proposed by astrophysicists to help make the universe be more understandable or make more sense to us. It's nature's most outrageous and strange number describing the rate of expansion of the universe. It effectively contains within it where the universe came from and what will happen in the future. Arguably, the search for the expansion rate of the universe was the holy grail of the 20th century in cosmology, and it continues to drive incredible new scientific theories and discoveries. The Hubble constant is named after American astronomer Edwin P. Hubble, who not only discovered galaxies outside our own, but also observed in the 1920s that these galaxies are moving away from Earth, and that the farther a galaxy is, the faster it appears to be moving away from us. So the race is on to figure out why. That's just about all we have time for today. Halley, anything to finish up from you?
Well, I have a query if you can help.
Sure.
If I use a standard star chart, how far is it from Betelgeuse to Procyon?
I don't have one in front of me. Sorry, I can't help you, Halley.
I'm just looking now, and I think the answer is 1.5 inches.
Oh, yeah. Very funny. Bye, Halley.
Bye.
And we're done for another day. Thanks for your company. Don't forget to visit our website where you can tap the Astronomy Daily tab and catch up on all of those stories and more, and download our free newsletter while you're at it, or sign up for it even, which will come into your inbox on a regular basis. And listen to back episodes of Astronomy Daily and Space Nuts while you're at it. Until next time, this is Andrew Dunkley for Astronomy Daily.
The Astronomy Daily Podcast
with Andrew Dunkley.